Welcome back to Teaching Statistical Thinking. This is our last core principle video for this part of the course. I want you to recall back to the very first video. In that video, we stated that you would start understanding the statistics that you see from breakfast to bedtime. Today, we're going to look at an example from the popular press and explore whether you've understood the concepts in that particular example. I hope you know who Nate Silver is. This particular example is from the Nate Silver blog site, and it was in an article written by Ben Castleman. The title of that article was, "States that already spent less on education have made bigger school cuts." In that posting, they presented this scatter plot. On the x-axis is per pupil spending in thousands. On the y-axis is the percent change in spending between 2009 and 2012, and it's been inflation adjusted. On the scatter plot are 51 points for the 50 states plus the District of Columbia. Now, to help you see if you understand the concepts that we've covered throughout this course, I'm going to bring in some Duke students to help me test your knowledge. So here we go. Our first student is Jeffrey. You ready to go, Jeffrey?
Yeah, sounds good.
Okay, I'm going to ask you a question, and I'm going to ask you to answer it.
All right.
From the scatter plot, can you draw the distribution of per pupil spending and estimate the mean and standard deviation?
Sounds good. Since we'll be drawing the distribution of per pupil spending, that's going to be a histogram illustrating what we can see in the scatter plot. Now, this is made a lot easier if we imagine that a grid is overlaid on top of the scatter plot. Since we have bin widths of 2 in our scatter plot already, that'll be really easy for us to just use the same bin widths in our histogram. So, if we imagine that there's a line between 6 and 8, and count the points in that region, 1, 2, 3, 4, we count 4 points in this first bin. So it's going to be approximately, yeah. We'll do the same with the next bin between 8 and 10, and that's 20 points. Next region has 11 points between 10 and 12. Just write those in. Between 12 and 14 we have about 7 points. Between 14 and 16 we have just about 3 points. We have 5 points between 16 and 18. And we have one final point in our last bin. Now, if we want to estimate the mean of this histogram, we'll imagine it as the point where if we balance a fulcrum, the histogram would balance perfectly. Since this histogram is skewed right, we see a significant tail at the right end, which means that our mean is going to be more right than the median would be. And if we look at this histogram, it looks like it would be approximately at 11. We want to imagine our fulcrum there. Now, our standard deviation looks like it's probably either 2 or 3, but because we have a heavy concentration here, and it looks like there's a long tail at the right end, we'll estimate that the standard deviation is approximately 3 in this example.
Great job, Jeffrey. Could you do the same thing for the percent change?
That sounds good. So we'll use the same strategy in making the histogram for percent change. We'll imagine a line here and count 1, 2, 3, 4, 5 points. And we'll do that for the rest of our bins. Our next region looks like it has about 8 points. Between 0 and -4 we have 9 points. between -4 and -8, we have 12 points. And between -8 and -12, we have 16 points. So I'll write those values in. And it looks like we have one final point that's below -12. So that's just 1. And once again, we're going to want to find the mean, and that's the point where the histogram would balance perfectly. And in this case, it looks like it's going to be approximately -4. And for our standard deviation, the bins are about 4, which looks approximately right for the standard deviation, but we also have to keep in mind that there's a heavy concentration of points in this bin, and there is a bit of a right skew also. So a standard deviation estimate of approximately 5 looks like it's going to make more sense.
Great job, Jeffrey. Now we're going to turn to Jake and Ella.